It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farming Nice Coffee.
Hi guys, welcome to the first video I'm putting together on naming structures. I'm going to put some together for each of the different functional groups. Hopefully it will help you out in terms of being able to name molecules and draw the structures appropriately as well. Alright, first of all I'm going to go through just some of the steps that goes for naming any organic molecule. Okay, what you need to do is firstly identify the functional groups. Okay, so use that functional group sheet that I've given you, or that you can grab off the website if you want as well. All right, and identify those functional groups. So if it's got alkenes, alkynes, aldehydes, carboxylic acid, ester functional groups, whatever it is, circle them, identify them, get to know those. Okay, then look for your longest carbon chain. Start from the end closest to where your functional group is, okay, and count how many carbons there are, and actually number them off, and I'll show you about that. Then write the name for the longest chain using the correct ending. When you're looking for the chain, make sure you have a look at any side branches, because sometimes the chain kinks as you go through. It's not necessarily in a straight line. Then put your side chains and branches out the front when you're naming it. Okay, follow those steps every time, right, and you should be fine. So I'm going to go through today and just show about naming alkanes, alkenes and alkynes, which are basically the basic skeletons of our organic molecules when we're doing our structures. So I'm just going to start with some basic ones to begin with. So I've got one here. Alright, so first of all we have to look to see if we can identify any functional groups. There's no double or triple bonds in here. All we've got is this little side chain down here. So what we do is we go through and we count the number of carbons in the longest chain. Okay, remember you can go sideways as well. So have a look. We can go 1, 2, 3, 4, 5. We can go 1, 2, 3, 4, 5. Okay, or the other way we can go is 3. Obviously 5 is the biggest number that we can do. Easiest way to do it is straight across in a line this time. So now we can start numbering our carbon atoms, and it's always easiest to number from the end closest to where we have any side chains or functional groups. So in this case we've got a little side chain here of a methyl group. Okay, so what we want to do is start numbering from here. So first, second, third, fourth, and fifth carbon. Okay, so because we've got 5 in a chain, okay, if it goes methyl, ethyl, propyl, butyl, pentyl, okay, so this is going to be pentane. Pentane, okay, and then on the second carbon we have a methyl group, so 1 carbon atom there. So this is 2 methyl pentane. Okay, so we counted our longest carbon chain of 5 atoms. Okay, we looked at on the second carbon we have a single carbon there. Okay, so we need to put down the number of where that single carbon is, because it's a 1 it's a methyl, if it was 2 it would be ethyl, if it was 3 it would be propyl. Okay, and then we have the carbon chain which is pentane. Alright, so that's just a fairly straightforward alkane to begin with. Alright, what I'm going to show you is how sometimes it can branch, and so it's really important to have a look at the longest carbon chain possible. Okay, here's the next one. Okay, so what we do, look again, there are no double or triple bonds in this one. So what we now start looking for is the longest carbon chain. So easiest way to start at the left. So go 1, 2, 3, 4, 5 that way. You can go 1, 2, 3, 4, 5, 6 that way. Okay, or you can go 1, 2, 3, 4, 5, 6. Okay, and also 6 is the longest we get. So not the straight chain this time, but actually this kinked form. Okay, so now we've got to look at the side group is actually this bit up here. Okay, so we've got 1, 2, 3, 4, 5, 6 in the longest chain, with a side group up here with 2 carbon atoms. Okay, we start numbering them from the end closest to where our side group is. So it's going to be this one here: 1, 2, 3, 4, 5, 6. If we started from this end, it would be 1, 2, 3, 4. Okay, so you always start from the end closest to where your side chain is. So here, because we've got 6, that's going to be hexane, because there's no double or triple bonds in there. And on the third carbon we've got 2 carbon atoms, so 2 is ethyl, so it's 3 ethyl hexane. Okay, notice for the number we use these little dashes in between each parts of the naming. Okay, and that's 3 ethyl hexane. That's looking at something that's not in a straight line. You could draw it in a straight line if you wanted, okay, but it's always best to try and count out all the different variations of your carbon atoms, work out what's the longest. Okay, what I'm going to show you now is an alkene. Okay, so I've got one here. Alright, so here we start to identify any functional groups. We can see we've got a double bond here, so straight away it tells us it's an alkene. We also look at our longest carbon chain. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or 1, 2, 3. So it's similar to the first one we did, except this time we've got an alkene, a double bond in there. So we start from the end closest to our alkene, all right, our double bond, which is this end. So it's 1, 2, 3, 4, 5. We've got a side branch up here. All right, it's always helpful if you can draw these out, number them, circle the side branches. It helps you when you're naming them. Okay, so because we've got 5, all right, that's going to be pent. All right, so it's pentene. Okay. And you notice I've left a gap in there because where we need to have the gap is to show where the double bond actually starts, because the double bond could start, could be here, it could be here, it could be here. Okay, all right, or if it goes here, all right, it's basically the same as at the start. If it goes here, it's the same as here. So we need to show which carbon atom it actually starts with. The double bond starts at the second one, so it's pent-2-ene. That's our carbon chain, and then we've got a methyl group on the fourth carbon. So it's 4-methyl pent-2-ene. Okay, looking at our longest chain again, we've got a side chain here and we've got a double bond in there, which is our alkene. So we name it as 4-methyl pent-2-ene. Next one I'm going to look at is an alkyne. Okay, here we've got an alkyne. So again, if you look for your functional groups, we see the triple bonds here. So we go, okay, that's an alkyne. And then we look to see if we've got any, what our longest carbon chain is. So we've got 1, 2, 3, 4, 5. There's no other options we can do. Okay, so now we start numbering. It doesn't matter if we go 1, 2, 3, 4, 5, or if we go 1, 2, 3, 4, 5, we're going to end up with the same thing. Okay, but what we do have here is now 2 triple bonds, so that affects how we name our molecule. There's no side chains coming off anywhere, no extra carbon atoms, so we're just going to have 5 in a row, so that's pent. Okay, now the triple bond starts on the first carbon, but it also has a triple bond starting on the fourth carbon, so it's 1, 4. Okay, and then because there's 2 of them, it's diene. Okay, so triple bonds give it the YNE ending. Okay, there's 2 of them, so we put a di in there. Okay, and then we show which carbons they start with, the first and the fourth, so it's 1, 4. If we numbered it this way, it'd still be 1, 4 diene, so it wouldn't really matter which way we changed it around. Okay, but anytime you have 2 of something, you put a di in. If there's 3 of it, you put tri. If there's 4 of them, you put tetra. Okay, so I'll show you a couple more of those a bit later on. Encourage you, if I'm going through this too quickly, just to pause, go back, look at them again, pause the video, have a look at the structure, see if you can work out why I've given the name I have. Now sometimes you're not going to always get these carbon chains in nice long single chains. Sometimes you're going to get things like this. Okay. Now what we've got here, and I've deliberately started to go from these full expanded structures like we had in the first one where I showed every carbon, every hydrogen bond, down to this one where I start to not show some things. Okay, when you have a shape like this, or anytime you have a little like point here in a diagram, that represents a carbon atom. So that's a carbon, 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 like that. Okay, you have a look at it now. This is not an aromatic functional group. If it was an aromatic functional group, you'd have 3 double bonds inside the ring, or you'd have a circle. Not aromatic. What it is an alkene. Okay, we've just got the double bond there. Okay, but it's in a cyclic structure. So what you do is you count how many carbons there are. 1, 2, 3, 4, 5, 6. So that makes it hexene. Okay. However, because it's cyclic, all right, we're going to call it cyclohexene. All right. Now it doesn't matter which. You don't have to put a number in this case because you're just telling it that there's a double bond within a ring structure of hexene. So if you see a cyclo out the front, it means it's in a ring. So you can have cyclobutane, which is 4 in a ring. It looks like a square. You have cyclopentane, which is a 5-membered ring. Okay. So if you see cyclo, it means ring. Count the number of carbon atoms. Look for any functional groups. If it was cyclohexane, there'd be no double bond there. All right. Here's the next one I'm going to look at. So now starting to combine a couple of things together, and I'm starting to do the condensed structural formulas now. You see I'm not drawing out all the carbon to hydrogen bonds. I've just shortened to CH3s and CH2s. Okay, so you still follow the same process. Look for any functional groups. There's no double, there's no triple bonds there. Okay, so it's an alkane. You now look for the longest carbon chain. straight across. 1, 2, 3, 4, 5, 6 across. If we go 1, 2, 3, 4, that's not as long. 1, 2, 3, 4 isn't as long. 1, 2, 3, 4 isn't as long. 1, 2, 3, 4, 5. So the longest we can get is 6, which is straight across. So we can start numbering them. This is the end that's closest to our side chains. So we circle our side chains here. Okay, there's 3 of them. We start numbering. 1, 2, 3, 4, 5, 6. So 6 of them makes a hexane. Okay, and what we've got is 1 carbon atom there, 1 carbon atom there, 1 carbon atom there. Okay, so on the second carbon atom, on the third one, and have the fourth one. So it's 2, 3, 4. On the second one we have a methyl group, on the third one we have a methyl group, fourth one we have a methyl group. There's 3 methyl groups in total, so it makes it trimethyl. Alright, so it's 2, 3, 4 trimethyl hexane. Okay, so 6 carbon atoms in the longest chain. We have on the second carbon atom we have a methyl, on the third a methyl, on the fourth a methyl. So 3 of them gives us tri. Okay, and we number where they are. Alright, if they were both here, it'd be 2, 2, 4 trimethyl. Okay, so you just put the number of the carbon atoms down where they are. Last one I'm going to show you is now where we've really condensed it down, and we've just got this. Okay, this is very, very common when looking at organic molecules, particularly just hydrocarbons, to save writing out your C's and your H's. Okay, so basically every point on the line, and what I mean by points I'll show you in a minute, every point is a carbon atom. So there's carbon there, 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 carbon there. Okay, always with these ones I recommend you drawing them and putting the carbons over the top. Alright, that's the first step. Okay, then what you can do is start putting in your hydrogens. Okay, this is to make sure that you haven't missed anything if you're trying to work out the formula. Remember, every carbon atom has 4 bonds, so you can start putting in your carbons. So 1, 2, 3 on that one, 1, 2 on that one, 1 on that one, 1, 2, 3. This one's got 1, 2, 3, 4 bonds around it already. That's got 4 bonds. There we go. Like that. Okay, this is helpful if you're trying to work out a molecular formula for them, which you sometimes need to do. But that just helps you to kind of visualize a bit more rather than just what's called a stick structure. Okay, you can actually start to see it a little bit more. So again, you look for your longest carbon chain. Pretty simple. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So the longest chain we have is 7. Look for your functional groups, which is your alkenes in this case, and we start numbering from the end closest. Okay, so this is 1, 2, third carbon, second carbon. So we're going to number from this one. 1, 2, 3, 4, 5, 6, 7. Okay, 7 of them makes it heptane. Sorry, mental blank there. Right, so it makes it heptene. Okay, so it's going to be E and E on the end. Okay, but we've got 2 of them, so it's going to become diene on there. And then we look at which carbon atoms they start. It starts at the second and it starts at the fourth. So it's 2, 4. So it's hept 2, 4 diene. And then here we have this extra carbon atom which wasn't part of our longest chain. So on the fourth one we've got a methyl group. Okay, so 4 methyl hept 2, 4 diene. Okay, so that's naming your alkenes, your alkanes, your alkynes. Okay, just your general skeleton structures. If you can start getting those ones right, when we start to go into alcohols, aldehydes, carboxylic acids, esters, and everything like that, it all flows really easily. So I suggest you watch this a couple of times. Make sure maybe you pause it before I write this, the name down. See if you can name it correctly as well. Then start going through your essentials workbook or looking on the web for different structures and making sure you can write them out. Also make sure you can go the other way. So make sure if you get a name like this that you can go in reverse and start doing it. And all you've got to do for that is write out your carbon chain and then put your side chains on it with your functional groups. Practice doing that as well because that's really, really important. Alright, hope this is helpful. There's going to be plenty more of these on drawing your structures. Practice, practice, practice. That's the best advice I can get, and follow those steps. Thanks guys. See ya.